Here I would like to describe to you what epithelial barrier theory is about. We have three major events taking place that interact with each other: epithelial barrier damage, microbial dysbiosis, and immune system activation. So the barrier theory includes all these three events taking place together in a very interrelated and overlapping events. It is an overarching theory about the hygiene hypothesis, biodiversity hypothesis, old friends hypothesis, ignorance hypothesis, danger hypothesis. All of them you can find within the epithelial barrier theory, and you can understand all of them also in a better way if you learn the epithelial barrier theory and follow these lectures. It is together with epithelial barrier damage and microbial dysbiosis and immune system activation, we have a metabolic component that affects the cells and cell mitochondria. There is a new concept which is being discussed, brain fog. What is it about? Chronic diseases. We have delayed healing time from surgeries and from diseases. There's chronic fatigue. And new diet is needed, and new diet is continuously being discussed. And what can we do to decrease inflammation? A new anti-inflammatory diet is very important. Hair loss is part of the hair epithelial barrier damage on the scalp, and there's expensive therapies are being used against epithelial barrier damaged individuals, such as biologics, which cost around 20,000-30,000 euro per year. And it is also fully about the gut-brain axis, gut-lung axis, lung-brain axis, gut-skin axis, skin-lung axis. These means that an inflammation starts from the gut but affects brain, an inflammation starts from the gut but affects the lung, and if an inflammation starts from the lung and affects the brain, and gut and skin inflammation are linked together. Skin and lung axis is happening when patients which have atopic dermatitis and develop asthma and also other respiratory diseases. And severe COVID is also within this concept. So what is this concept? It is about epithelial cells. The surface of our body is not touching each other. Normally, they should touch each other very tightly, that even water should not pass through. But what we are seeing is that there's allergens, pollutants that are going in between the epithelial cells. And we identified many substances in the lab that specifically damage the epithelial cells in very low doses. And if you increase the dose a little bit high, they start to damage the microbiome. And there is laundry and dishwasher detergents, that surfactants, sodium dodecyl sulfate or sodium lauryl sulfate, it is the same substance, sodium dodecyl benzene sulfonate, shampoos and body cleaners that have mainly sodium dodecyl sulfate, household cleaners, and unfortunately, toothpastes are containing sodium dodecyl sulfate, sodium lauryl sulfate around 2000, the year 2000, which is nowadays linked to development of eosinophilic esophagitis by the Mayo Clinic group. The second group is enzymes and emulsifiers in processed food. Processed food was entered to our lives in the year around 1980s. When we come to 2000s, we were seeing that the shelves of the supermarkets are continuously being changed every 7 days, because the shelf life of many foods like pizza or sauces were about 7 days, about 25 years ago. Currently, you go to the same supermarket, you take a pizza and look at its bag, it has a shelf life of 1 year. So what happened that the shelf life of a pizza increased from 7 days to 1 year? It is because there was emulsifiers and additive antibiotic-like substances were added to pizzas and sauces and many packaged food, many processed food. And then this changed also how our body reacts to these food, because these substances were understood nowadays that they are toxic. They are affecting the mitochondria, they are affecting the DNA, they are affecting the oxidative stress of the cells, so they are killing the cells. And then the third group is air pollution group. Here we have cigarette smoke, diesel exhaust, ozone, nanoparticles, particulate matter, and micro and nanoplastic, although they affect all organ systems. They are inhaled and they are eaten up, they are drinking with water, and they are also affecting the skin. So micro and nanoplastics are very major in this list. We have allergens and house dust mites. They break also tissue barriers. And we have classical infections like bacteria, fungus, viruses, and parasites. And these classical infections also damage the epithelial barriers. But when these infections heal, the barrier closes. But when we are continuously exposed to these substances, our respiratory barrier, gut barrier, and skin barrier are damaged in a way that a chronic inflammation starts. So these microbes go deeper in the tissues, and there is a microbial translocation, which we can see in our gut biopsies very easily, or also in chronic rhinosinusitis biopsies, in skin biopsies, that the microbes are going deeper in the tissues. And these substances also have a synergistic effect. Epithelial barrier damaging effect and pro-inflammatory effects are working in a synergy. Just think of a patient with house dust mite allergy is exposed to laundry and dishwasher detergents, is also exposed to particulate matter in the house, and is continuously eating up processed food. So this is quite bad. Then allergens, toxins, pollutants, microbiome, and opportunistic pathogens are passing deeper in the tissues. And in all of these substances, the dose is very decisive. I would like to quote here Paracelsus. He was the pharmacist of Canton Schwyz in Switzerland, and he lived in 1493 to 1541. In around 1520s, he said, "Solo dosis facit venenum." That means all things are poison and nothing is without poison. Only the dose makes things is no poison, or the dose makes the poison. In principle, this is very true still, and there is no difference in this discovery of Paracelsus. And in the epithelial barrier damaging substances, the dose is very, very important. And here we can see that the epithelial cells are not touching each other. The microbiome goes in between the epithelial cells. This is that thing, this is the respiratory epithelial cells. And deeper inside the epithelium, after this migration of the microbiome, there is lots of commensals, and opportunistic pathogens colonize, like Staphylococcus, Moraxella, Haemophilus, Pneumococcus are the opportunistic pathogens for the respiratory area. And we are seeing that microbes are translocated to deeper tissues, and the epithelium responds to this periepithelial inflammation by inflammasome activation and IL-1 release, by alarmins, IL-25, IL-33, and TSLP, and by multiple chemokines. And just tells the immune system, please come and help, because microbes and many substances are passing my barriers, going to deeper tissues. These substances may be dangerous. Let's together fight with this. And the immune system is invited to the area. This is a very typical asthma picture. In this graph, you can see that there's eosinophils, there is type 2 innate lymphoid cells, Th2 cells, B cells, dendritic cells, macrophages, and it's like a eosinophilic type 2 inflammation. That's what we are seeing here. I would like to stop here for this part. Thank you for your attention.